Now, you have to worry about how to do long division. Well, I'm going to rewrite this guy down here. Now that we've taken care of this number one step, let's do number two. X minus 3 into 3x squared plus 2x plus 5. Now I don't have to rewrite concerning the exponents because now we've checked it to make sure everything's in place. Now what I have to worry about is what do we concentrate on? Because I still remember to this day how it felt the first time I saw long division. And I said to myself, how in the world, I'm used to doing this. I'm used to doing 2 into 7. 2 will go into 7 3 times. That'd be 6. You always subtract, and that'd be 1 and 1 over 2. That's how I always envisioned division. And then when I got to this, I was like, how in the world can you think of dividing this into something like this? And I came up with the kite and the tail. Now, if you see this in any kind of book, I know they stole it from me because that's what I did. I divided up into a kite and a tail. Why a kite and a tail? Because this 3 is useless to us. We do not care about this 3 as far as priority. What do we care about? Well, what tells the kite? What tells the tail what to do? Kite. The tail follows the kite. So you don't worry about the 3. You worry about what? The x. And you say to yourself, how many times will x go into 3x squared? Now, remember, you're dealing with exponents here, and you're thinking about multiplication. And what do you do with multiplication and division of, we multiply exponents with the same base? What do you do? You add them. What do you do when you divide? Subtract them. So I don't want anybody saying, okay, x will go into 3x squared times. Because that's what the students usually do. Or 2x times. That's what they usually do. Okay, let's do that. X to the first, or 1 will go into 3 how many times? 3 times. How many times will x to the first go into x squared? X to the what? I'm going to put that in blue. X to the first. Because 1 plus 1 is what? 2. Or 2 minus 1 is 1. And that, if you don't screw this up, this right here is where you're going to screw up. If you get this right, this is where you're going to screw up. Now, we go back to our division back in 3rd, 4th, 12th grade, whichever one you were. And we say 2 will go into 7 how many times? 3 times, and then we do what? 3 times 2 is 6. So we go down here and we say 3x to the first times 1x to the first is what? 3x squared. And now we worry about the tail. What's 3x times 3? Is that a plus or minus? Minus. All right, 3x times a negative 3 is negative what? 9x. Now let's go back to our 3rd grade problem. What do we always do when we have that 6 down there? What do we always do here? You always subtract. So I'm going to take my handy dandy red marker and I'm going to put a subtraction symbol out here. And then draw my red line.
You're going to add on that, right?
Well, you can do this 2 ways. One, you can say 3x squared minus 3x squared and 2x minus a negative 9x. You can do it that way. Or you can distribute the what? you can distribute the negative. So what I'm going to do is I'm going to take my handy dandy box, and it's not going to cooperate. So I don't know why I even thought I'd do that, but I was going to take it and make it a little bit smaller. Nope, it's not going to let me do it. Okay, so what I'll do is I'll take it over to the next page. Let's go to the next page. X, I'm going to draw two of them. Over here, x minus 1. X minus 1 into 3x squared plus what?
Minus 2x plus 5.
Minus 2x plus 5.
X minus 3.
What?
X minus 3.
So X minus 1.
Oh, okay. X minus 3. And then I'm going to take that, and I'm doing this for a reason, just bear with me for a second. And copy. And paste. I got it on clipboard, so I'll just do it later. All right, so I went ahead and I said x to x will go into 3x squared, 3x times, and I went 3x times this is 3x squared, and I went 3 times negative 3 is what? Negative 9x, and then I go out here and put a big negative. All right, that's one way of doing it. Another way of doing it, more than one way to put it. Good job. Your parents did good. All right. Some of y'all are, All right. X will go into 3x squared, 3x times. 3x times 3x, or x is 3x squared. And 3x times negative 3 is negative 9x. And instead of subtracting, I'm going to distribute the negative. I'm going to distribute this negative, and what will I get? A negative. I'll make that a little negative and make this a positive. Now that's the two ways that you can do it. In other words, don't distribute the negative and just say 3x squared minus 3x squared and negative 2x minus a negative 9x. Or you can distribute the big negative, which will make it a little negative and a little positive, and just add them together. Now the reason I spend that much time talking about this is because besides as the most confusing part of long division, besides how do I divide x minus 3 into a trinomial, besides that being confusing, this is the most confusing part for students. They don't know which one to do, or they don't stick with one, or they don't understand how I do this when I got this on the board, so that's why I showed two different ways. So either way, what's going to happen? What's going to happen to your left-hand term? That's going to cancel. And is that supposed to happen every time? Yes. The left-hand term is supposed to cancel. And then, just like you did before on the 3 into 7, you add what's left. So negative 2x minus a negative 9x is what?
Negative, or 7x.
Be 7x, and then you bring the 5 down to help out.
I was putting that
Look over here. Negative 2x plus 9x is 7x, and then the 5 comes down to help out. And then you finish it by saying, how many times will x? There's the type. How many times will x go into 7x? Plus 7 times. 7 times x is 7x. And 7 times negative 3 is what? Negative 21. with a big subtraction symbol, or 7x minus 21, and then we take take the big negative and distribute it, and that becomes that. And what happens to the left-hand term? It cancels. That's supposed to happen. And what's left over? 5 plus 21 is 26 remainder. And what happened here?
I was just about to ask that.
I'm on drugs, I guess. I don't know. Just 7 times 3 is 25. I guess y'all probably figured out to catch it before long, so I'm glad I did. All right, and I'm glad y'all ain't all saying at the same time, yeah, I was wondering about that. And Bubba's on the back row going, yeah, man, you wrong. What's wrong? I don't know. I'm just going to say you're wrong just because I don't like you. Anyway, 5 plus 21 is 26 remainder. Now, there's two ways you can write the answer. And that is 3x plus 7, comma, 26 over x minus 3. That's one way of writing the answer. Another way of writing the answer is 3x plus 7 with a remainder of 26. Doesn't matter to me which way you write it, as long as you show it as a remainder. They just have different ways of writing. In other words,
In one box, with 2 answers.
one box, two answers.
3x plus 7, comma, 26 over x minus 3, so 2 separate answers.
No, it's not two separate answers. This is one answer. This is one answer right here. Like 2 will go into 7 3 times. 3 times, that's 6. 1/2.
Right.
That's what you got right here. The reason I put a comma here is because if you was to write all this together like this, it might be confusing to somebody. Unless you do something like this. Hold on. Unless you write it like 3x plus 7, and then out here go 26 over x minus 3, like that, or put parentheses around it or something. See, you see how this can look like it's part of it, it can look funky. That's why people do this. Because you're hurried up on a test, 3x plus 7, 26 over x minus 3. You see how it can be messed up. That's why. So you don't want to do this. If you're going to write the remainder over the denominator, do it this way with a comma. And a lot of people are used to doing this, and they get confused when they see an answer written like this. Both of them are the same. Alright, so let's do a nerd. I'd like to do one that's got missing terms. Ooh. Here we go. Let's do this one. This one is can you read it? It's too small. It's on page 228. Yeah. Right here. 3x cubed. It's going to be x minus 3 into 3x cubed minus 2x plus 5. So go ahead, and this is example number, I don't know what's this, only on page 228. And we're going to copy that. And we'll take it over to whiteboard and bring it back. So what I want you to do, the only thing I want you to do, I mean, you can work it if you want to, but those of you that are a little bit gun shy around long division, all I want you to do is put in the missing value that you need to put in. There is a missing value. In other words, there's a place value that needs to be, something needs to be put in its place. So I'm going to write everything in terms of its exponents. X and minus 3, and then 3x minus 2x plus 5. Then I'm going to take my red marker, and this is 1x to the first minus 3x to the 0, 3x to the third minus 2x to the what? First, plus 5x to the 0. So once you put it in terms of everything has a variable and everything has an exponent, once you do that, let's check the left-hand side. Is everything there? 1, 0. Yes, that's good. Let's check the right hand. 3, 1, 0. Is anything missing? Yes. The x squared function is missing. Now again, I do realize that most of you, I'd say 95% of you probably, have had long division before. But I guarantee you there's one or two in here that are rusty or have never understood it. And that's why I'm going through this. And you're going to see it a lot in Calc 1. So I'm going to rewrite this guy, the whole thing, but this time I'm going to put in the missing term. So x minus 3, and then that's going to be 3x to the third plus 0 x squared minus 2x plus 5. And there is where I put that in there. Now some people just put a space. And that's fine. A lot of people will write it like this. X minus 3. And then they'll just do this. 3x to the third minus 2x plus 5. Some people put in a plus blank. Some people do that. Some people just leave it blank. Some people do this. Whichever way you do it is fine with me. I really don't care as long as you use long division and as long as you realize that something is missing. I don't care how you do it. Okay, so let's take it to the next page. Really? Sorry. Hit the wrong button. I use 0, so shoot me. I just don't like to just have a blank there. That messes with my head, so I don't like doing it. All right. So how many times, here's my kite, here's my tail, so I'm not worried about this. How many times will x go into 3x cubed? 3x squared. 3x squared times x is 3x to the third. 3x squared times negative 3 is what? 9x squared, negative 9x squared. And I do not use the big subtraction symbol, I distribute. So I use the little red negative here and a little positive there. That's what I do. You decide what you want to do, but you're going to get the same answer. And what happens to this term? It cancels. And you're left with 9x squared. And the negative 2x comes down to help out. And how many times will x go into 9x squared? 9x times x is 9x squared. And what's 9x times negative 3? And then we take our red marker, and I put a little negative here, and I put a little positive there. And I get, of course, the first one goes out like it's supposed to. Wrong thing. It goes out like it's supposed to. And what's negative 2 plus 27? And the 5 comes down to help out. And how many times will x go into 25x? 25 times x is 25x. 25 times negative 3 is negative what? And we always subtract. And that's going to give me, of course, that guy goes out. And that's going to give me 5 plus 75 is what? 80 remainder. So your final answer is how many times will x minus 3 go into this? It'll go in 3x squared plus 9x plus 25 with a remainder of 80, or 3x squared plus 9x plus 25, 80 over x minus 3. And that's your two possible answers. Long division is not hard. Long division is just like you're completing a square. You have to do it in a step-by-step, orderly fashion. If you try to do it in an inconsistent, fast, I can do it between the blue lines of my notebook paper, you're going to get them wrong every single time. You've got to find your own little method or use this method and just do it very systematic, very methodical, same way every single time, and you won't get them wrong. Or you could get discouraged and quit. And I always encourage that. That's always the easiest route to go. Right? Y'all are learning. Don't tell me y'all can't learn to do new things. I don't know what's gotten into all these teachers always trying to encourage students. That's the most difficult route to go. All right, let's try this one right here, even though it says synthetic. Ignore the instructions. I'll blow it up for you, and I'm going to let y'all do this one. Just ignore the directions unless you just want to learn two ways. And I don't suggest that, because when you get to calculus, most of your problems that you can do in calculus are going to have to be done long division, because sometimes that's going to be an x squared value. And if that's an x squared value, you're going to have to use long division. What's this classroom? 242? All right, I'm going to write this one down, and I'm going to go ahead and skip a step by putting in the missing value if we have one missing. I don't know if we do or not. So x plus 2 into, let's see, 3, 2, 1, 0. So everything's good. 5x cubed minus 6x squared minus 28x plus what? 8. Everything look good? 3, 2, 1, 0. 1, 0. So everything's good. So how many times will x go into 5x cubed? 5x squared. 5x squared times x is 5x cubed. 5x squared times 2 is what? 10x squared. We always subtract. So that's going to make this guy a little negative and make this guy a little negative. And of course, that one goes out. And what is 6x, negative 6x squared minus 10x squared? Negative 16x squared, and the negative 28x comes down to help out. How many times will x go into negative 16x squared? 16x, negative 16x times x is negative 16x squared. Negative 16x times 2 is negative what? 32x. Distribute the little negative, and that'll make this what? Positive, and make this positive. And what happens to the first term? It goes out. Negative 28 plus 32 is what? 4x, Hubert. That's right, class. Plus 8. And how many times will x go into 4x? 4 times, Hubert. 4 times x is, and 4 times 2 is, and our minus symbol makes this a negative and this a negative. Oh my, look at there. What happens? Well, this cancels, and what does 8 do? And you're left with a 0 what? Remainder. So, the answer is 5x squared minus 16x plus 4. So, technically, this is an even factor. If you take x plus 2 and multiply it by this guy, you're going to get 5x cubed minus 6x squared minus 28x plus 8. In other words, it's an even factor. It don't have a remainder. Just like 2 times 3 is 6. How many times will 3 go into 6? 2 times with no remainder. So this is an even factor problem. Like 7 or 2 will go into 6 3 times. 6, 0 remainder. 3 times 2 is equal to 6. This times this is equal to that. Comprende? I want to find one that is, yes, sir.
Could you do this problem?
No.
Just one additional.
All right, hold on. Which one is it? You'll send it to me?
On 17.
All right. Oh, and then I watched another stupid movie. Oh my gosh. This movie was called, I can't even remember the name of it, but it was about this college group of kids going into the woods. Have you seen this? College kids going into the woods, and they're all going to go to this, they're going to have a big party, and while they're on the road, they meet these two guys that are country boys, and they think they're hillbilly killers, like on Wrong Turn, 1 through 500.
I know what you're talking about. Is it Tucker and Dale versus Evil?
And, huh?
Is it Tucker and Dale versus
Yeah.
Yeah.
And the college kids all kill each other, trying to kill the two guys, and the two guys are like, what's going on?
It's ridiculous.
It's a ridiculously stupid movie.
It's funny though.
Yeah, it is. It is funny, especially when everybody starts. The one guy throws himself into a wood chipper, and the other one stabs himself, and it's just that's funny. And the two rednecks, they're just like, these guys are killing themselves. They're doing a suicide pact. It's funny. And what's it called again?
Tucker and Dale versus Evil.
Tucker and Dale versus Evil.
Yeah.
It's funny.
I think at one point too, like a cop shows up and he leans.
And he leans on a thing, and the board comes down and hits him in the head and puts a nail in his head, and he dies. I mean, just everybody that comes around these two guys die, and everybody thinks that and the college kids, they all kill themselves off, except for one at the end. It's real stupid. Okay, this is the one I was looking for. Here we go. All right, so go ahead and write that one down. And I got to do the roll while I'm got my email open. So I'm glad you sent this one, because that's the one I was looking for. One that has missing values, and it's also more than 3 terms. So I wouldn't do a half a sheet of paper. I'd probably start at the top of a sheet if I was you. So you have plenty of room. It is, thank you. I turned it off a while ago when I took the attendance. Thank you. So let me just put that back. All right. Let me move it. Well, I tried to move it, so it's not letting me. Let me try something. Let me try this. No, it ain't gonna work, so y'all just have to bear with me. All right, how many times will 5x go into 0x squared? 0x times 0x times 5x is 0x squared. And 0 times -4 is positive 0x. And I'm going to put a line there, but we're going to write the answer over here. And that's going to be that one cancels. And what is 10x plus 0x? 10x, and that negative 13 comes down to help out. And how many times will 5x go into 10x? 2 times. 2 times 5 is 10x. And 2 times negative 4 is what? Negative 8. And we always subtract. And of course, that goes out. And what's negative 13 plus 8? Negative 5. So our final answer for this guy is 1x to the third plus 0x squared plus 0x plus 2 comma negative 5 over 5x minus 4. And of course, we don't need what? We don't need those guys. So your final answer, all cleaned up, is x to the third plus 2 negative 5 over 5x minus 4. Or x cubed plus 2 comma r negative 5. And that's a prime example of what to do when it's not like the first problem we did. If it's not like the first problem, the key thing is to make sure that all place values are what? Accounted for. And then you do the process over and over and over. And when you hit a stump like this, you just keep going and say 5x will go into 0x 0 times. And you fill in those plots. And once you fill in those plots, once you fill them in, you get your answer. Then you can take those two out, and you're left with that answer. Okay. The only other one I would suggest that you try to do is one that is divided by 5x squared minus 4. And that would be, if this was 5x squared minus 4, this is how you would do it. And I'm just going to show you this before I show you the test. So don't start packing up yet. 5x squared plus what? 0x minus what? 4 into 5x to the fourth minus 4x to the third plus 0x squared plus 10x minus 13. And just like the last problem we did, you have a term there, but what else? You have a term here because 5x squared minus 4, I changed the problem. 5x squared minus 4 is missing that spot right there. And now you follow the same, I'll start you off. 5x squared will go in here. X what? X squared times, that's 5x squared, x to the fourth. Huh? Yeah. 5x squared will go into this, x squared times. Alright? And then x squared times this is plus 0x cubed. And x squared times negative 4 is negative 4x squared. And you always subtract. And that would be a negative here, and a plus here. And the first term cancels out. And that'll leave you with negative 4x cubed, 0x squared plus 4x squared is plus 4x squared. And then the 10x does what? Helps out. And now you've got another 3-term polynomial to match this 3-term polynomial. And you keep going. Same process over and over and over. until you get down to a zero remainder or a number remainder.
So in this next step, are you gonna have fractions? Then? Is that so?
5x, well, yeah. You know, well, yeah, because 5 won't go into 4 real nice. Notice how it happens when you make it up. So you're going to have to multiply 5 with 5x is equal to -4, and divide by x. Divide by 5. So that's going to be negative what? -4/5 x. And -4/5 x times this is what? -4x cubed. And then you have to, this is 0x squared. And then -4/5 times this is -16/5 x, or positive 16/5 x. And then you always subtract. And that's going to be a positive, a negative, and a negative. And that goes out. And you're left with 4x squared. 10 changes into what? 50 over 5x. 50 minus 16 is what? 34 fifths x. And then y'all finish it out by multiplying again by -4/5 or +4/5. And that's 13, -13. And that should get that to get down to a number. The reason I did this, not so you could finish the problem, I did this, the 5x squared minus 4, just so you would see this. I'm not really concerned about you finishing this problem that I just did, because that's a more complex problem. And most of your problems on the test are going to be ones like we've been doing. I just wanted to make sure you understood that not only can you miss a term in the radicand, you can also be missing a term where? In the divisor. Okay? You can miss a term, and if there's a term missing, you've got to put something in there. Yes, sir?
So your remainder is going to be that problem on the bottom?
No, you got to go one more.
Yes.
4/5 times this is 4x squared. 4/5 times 0 is 0. And 4/5 times this is 16/5. And that'd be a -16/5. You have to change this 13 to what? 80/5 or something like that? Or 80, whatever it comes out to
Do
be.
you have a variable in your remainder?
Yeah, if this is to the x squared, then yes, you probably have another variable in the. If it's x to the third, you're going to have 2 variables left. If it's x to the fourth, you're going to have 3 variables. So it depends on the leading coefficient in the divisor. Okay, so that's 3 or 4 that we've done, and they're the same. In other words, you just fill in, and the process is the same. We've got about 4 minutes, so let's just look at the test right quick, just so you can look at it, show you what kind of problems on it, and make sure I hadn't put anything crazy on there. Well, where'd it go? Where's my... Okay, I'll get there in a second, y'all. Hold on. There we go. Test. And there it is. Unit 2, Chapter 3. I'm ready. I'm ready. I'm ready. Okay, that's an easy question. Okay, that's your conjugate. Again, complete and square. What they want? They want the vertex and match it up. This one, domain and range. Vertex, complete and square. No, they already done the complete and square for you. All you got to do is negative. Now this one is in intercept form, so it'd be -4, +3, because it's in that form. Solve by completing the square. Make sure you can do the i's. What is I squared?
-1.
So -1 is going to combine two of the numbers. Don't forget that. There's another one. Complete and square. It says for the following, use the vertex formula, blah, blah, blah. Just ignore that. They want the vertex, use complete and square. This is a calculator question, so y'all can do that. The calculator is a cubic function, so it's going to have something like that right there, or this one. This is a parabolic, and this one looks like a parabolic, so I'd say it's either of these two right here, but I hadn't had a chance to look at it. But that's a calculator question also. Complete and square. Ending behavior. This is x to the 10,648. Which way is it? Is it parabolic or is it an S? Which one is it? Parabolic. Is it positive or negative? Positive, so it'd be B. Solve by completing the square. Solve the equation by completing the square. We did that one in class the other day. Solve by completing the square. Multiply the i's. Solve by completing the square. I hope it didn't give you the same numbers. Solve by completing the square. Now all they're looking for is the x-intercepts. You have to find the vertex if they just say solve. No, you don't have to find the vertex. And same type problems over and over. Is that it? That's it. I think I answered one, didn't I? Did I get it right? Yeah, I did. All right? All right, y'all get out of here. Have a good day.